alright, if you look at the function here, was x square root of 8 minus x squared. Notice that this has got to be positive, so for the domain, this has got to be greater than equal to this. Alright, and so we need to always remember that we have this restriction on the domain here, that 8 minus x squared must be always greater than or equal to 0. Okay. Alright, now if that's the case, you'll notice that if greater than or equal to 0 will mean that it has to fit in between negative 2 root 2 and 2 root 2. For example, if I take something like 3 out there, you notice you'll get a 3 squared is 9, 8 minus 9 is negative 1, and so we don't get a real number here. So it's got to be inside these two values, negative 2 root 2 and root 2. Now we're looking at the derivative here, so always keep in mind that we're looking at the derivative f dash of x. So I've just put that on the end of the line there to remind myself that this is the derivative that we're looking at. Alright, so remember that the derivative was this, okay, and it was 8 minus 2x squared over the square root of 8 minus x squared. Now the reason I've got that is because I now want to look at what the sign of this, whether it's positive or negative, when we get to some of these values inside these intervals. So notice we have 1, 2, 3 different intervals here. 0 is easy. If I put 0 in here, I get 8 on the top and I get the square root of 8 on the bottom, so that's clearly positive. And a positive slope goes up. So I'll put a slope like this. Now if I come down to here, in between 2 and the square root of 2, to something like 2.5, the denominator is always positive. 2.5 okay, squared is going to be less than 8, so this is all positive under here. Now also notice if I put 2.5 squared in here and times it by 2, alright, we're going to get a negative number on top, and so that means that this is negative here. Okay, now notice that we have an x squared here, and so when I come across here to this region, the same thing's going to happen if I try a negative 2.5, for example, in here. Right, so we have a negative here. So we can now see when it's going to be increasing and when it's going to be decreasing. So the intervals of increasing is going to be between negative 2 and 2. It's going to be decreasing, right, from negative 2 root 2 to negative 2. And we're going to combine that with this one over here, which is 2 root 2. And so that's where it's going to be decreasing. Alright, so we now have answered part, we've now answered part A. Now part B has to do with identifying local extreme values. Alright, so part B, find local extreme values. Now if you look at your the picture that we have here, okay, I've written the slopes like this because this tells me now exactly where I have local extreme values. In fact, I have a local minimum when x equals negative 2. I have a local maximum when x equals 2. Right, now also you'll notice here that this comes down to here at 2 root 2, so this here is going to be a local minimum as well. So we need to do 2 root 2. And of course we're going to have over here, notice that this one here is coming down from here, so this one would be a local maximum. Okay. Alrighty, so we now need to look at what the values of these are, so we can make up a little table. Alright, and we'll put the critical point. Okay, and we're going to have negative 2 root 2, let's do that one, negative 2, I'll do them in order, 2 root 2. Okay, so they're the values. Alright, now this is extreme value. Alright, type, if you like. So at the moment we have a this one is a max, a local max. This one here is a local minimum. 2 is going to be a local maximum, and the last one is a local minimum. Now let's look at the actual value of the function at those 2 points. Alright, so remember our function was f of x equals x square root of 8 minus x squared. So we're now going to put these values in here. So notice what happens here when I put negative 2 root 2 in here. Well, we can see clearly what's going to happen. This is just negative the square root of 8. When I square it I get 8, so I get 0 here. Okay, so we get a value of 0 for the function at that point. Notice that for this local minimum down here we'll get a 0 as well. Because of the squared it makes no difference. Right, now let's put in negative 2. If I put negative 2 in here, I'm going to have 4. 8 minus 4 is 4. Square root of 4 is 2. And we have 2 times 2, so that would be negative 2, so would there be negative 4. Okay, so negative 2 in here would give me 4. 8 minus 4 is 4. Square root of 4 is 2. Negative 2 by 2 is negative 4. When I do 2 in here, I get 2 squared is 4. 8 minus 4 is 4. Square root of 4 is 2. Times 2 is 4. Okay, so straight away we see here that this is a absolute minimum. It's the smallest and it's in the domain, and this one is an absolute maximum. So what we would say is that this function, alright, has an absolute minimum when x is equal to negative 2 of negative 4, and it has an absolute maximum when x is equal to 2 of 4. Okay, and that's how we do a problem like that.